Hello, friends. Podcast to introduce section 7.2 in the AP statistics book. We're talking about means and variances of random variables. And remember earlier we said that a random variable x is a variable whose number can take any, is the result of any random event. All right, so now we are going to start looking at what happens when we repeat a random event a large number of times and find the average of all those outcomes. So now we're going to get an average, and this will generate a continuous distribution as opposed to discrete. And with this we can find a mean, which tells us the expected value. In other words, what we expect to happen if we repeat a random event a lot of times. So we're going to take, again, a bunch of things we already know. We have a probability model right here. And this is the payout on a pick 3 ticket. You can pause the podcast and read the problem if you want to. But there's only two possible outcomes. You buy a ticket for $1, you win nothing, or you win $500. Now, you're picking a 3-digit number from 000 to 999, so there's 1,000 possible outcomes. There's one way to win. So you have a 1 in 1,000 chance of winning, and you have a 999 chance in 1,000 of losing. To find the expected value, in other words, how much money would I make on each ticket if I repeated this random event a lot of times, I multiply each, let me do it with a different color, each random variable right here by its probability. So this is the probability I got from here, and this is the x right there, and this is its probability right here. So I multiply each one of these together. In this case there's only two, and then I add those two things together. So if I buy these tickets for $1 and I buy one every day for 10 years, I would expect on average to win 50 cents each time. Of course, that also means I'm losing 50 cents of my dollar each time. So that's how the games are set up. That's how Vegas sets up their games as well. They know if a lot of people gamble in a casino in Vegas, they're going to get a very small percentage, but they're going to get that percentage on average from everyone that comes through the door, and they can count on a lot of people being there. So more stuff we're pulling back from our past. The mean of this distribution is going to be mu, the Greek letter mu. Remember, we did this earlier in the year when we talked about the mean of a population, and x bar was the mean of a sample. And this expected value is really the same thing. It's the mu. It's what would I get if I repeated the random event a lot of times. So this is a sort of formal explanation. Okay, I take every one of these random variables, x, every possible outcome multiplied by its probability, and I add each one together after I multiply them. And the sum of that, there's my Greek letter sigma again, the sum of that is the expected value. So let's take a look at what this really means. I have here a little applet that you can get to on the website for your textbook. And what I'm doing here is I'm rolling 2 dice. And there are when I roll 2 dice, there are possible outcomes, possible values for these dice are everything between 2 and 12. And if I multiplied each of those outcomes by its probability, in other words, the probability of getting 2 is 1 out of 36. The probability of getting 7 is 6 out of 36. So if I multiplied each of those outcomes times its probability and added them up, the mean would be at 7, which is right here. Now here's what's going to happen. I roll these dice. So I roll the first time and I get an 8. There's my 8. I roll a second time and I get a 7. So 8 plus 7, 15 divided by 2, 7.5. There's my average. Now this is higher than what I expect. But what you're going to find is, as I continue to roll these dice, my average will approach and then stay closer and closer to what I expect it to be. So I'm going to change and roll these 20 at a time. So you can see all I did was change this number to 20. So now I'm going to roll them. And you'll see they'll just roll and continue to build. And it's still above, but it'll come down. There they go. Now I'm going to do 20 more. And there they are rolling. And they're actually staying pretty high, but here it comes down now. And if I continue to do this, this red line, which represents the average, is going to get closer and closer. And eventually, if I do it enough times, it's just going to hug this green mean line. So that's what expected value tells us. What would happen if I repeat the random event a lot of times? Talk about it more tomorrow in class.